Now this is a shape question, and we're asked to try and work out some shapes for a fictitious molecule, ZF4. And if it's ZF4 and it's tetrahedral, that means it's got 4 bonding atoms or groups around it. And in this case, that means we'll have 1 electron from Z for each F, which means there's got to be 4 valency electrons, which means for the tetrahedral shape it must come from group 14, something like carbon or something like that, silicon maybe. So if we were to do that, we could have this as being a possible Lewis diagram for that, and that would obviously, if it's got 4 of the same atoms around it like this, and a symmetrical shape, then would be looking at something that would be non-polar. And so this doesn't seem a likely choice. If we were to look at changing this to a seesaw shape, that means we're going to have this based on 5 pairs. So if we've got it based on 5 pairs, and we've got 4 bonding and 1 non-bonding, that means that we've got to have 6 electrons in here around the central atom. So in this case, this could be something like sulfur, for instance, and then in the middle we'd have that, 4 fluorines again, and a lone pair of electrons there, and then once again just drawing in the fluorines. Now this is the seesaw structure, and let's just check that's okay. So that's 4 bonding pairs and 1 non-bonding. Now this is a polar structure because we've got this lone pair of electrons here. It tends to lose well, I shouldn't say lose, but the lone pair tends to be around the equatorial position. This is the equator around the middle, and that's because it minimizes repulsions. Okay, there's less repulsion here than there is if it was to be lost at the top of the bottom at the poles. So that would be a polar molecule. Now the other possibility, of course, is if we had a square planar. Now that would mean we'd need to have 4 bonding and 2 non-bonding. So we'd need an extra 4 electrons, which means it must come from group 18 being something like xenon or something like that. Alright, now the Lewis diagram for that would look something like this, and this, and the shape of that would be square planar. So because it's symmetrical, obviously the lone pairs would be at either end. That would create the least repulsion, here and here. And because the remaining fluorines that are bonding are placed around the central atom, that would be non-polar, okay, because of the symmetry there. So the only one that actually works for that is obviously the one with the seesaw shape, and that's the one that's polar as per a question. Now in answering this, obviously you need to go through and make sure point by point you explain how you arrived at the shape. The fact that with this one, the tetrahedral one, you're going to have no lone pairs, that they will be repelling each other, and that there's some symmetry about it, and therefore because of the same electronegativity on all the fluorines, that it's going to end up being a nonpolar molecule, and that the dipoles that do exist between, for instance, a carbon and a fluorine, or a silicon and a fluorine, that would be cancelled out because of the symmetry. Then we move on to the possibility of the seesaw shape, that again the electrons take up the position based on electron repulsion, that there's 5 that are bonding, 1 that is non-bonding, and it's maybe based on a trigonal bipyramid shape, but the actual shape is seesaw. The lone pair is around the equator. to minimize repulsions, and because of the asymmetry around there, the dipoles wouldn't cancel from the bonding between, for instance, a sulfur and fluorine, and we'd end up with a polar molecule. And the square planar one, which we've just talked about, the xenon would have 4 fluorine bonding around the equator with the non-bonding pairs at the poles, because that would minimize repulsions again. And the overall symmetry would mean, even though we may get a dipole between the xenon and the fluorine, that would end up cancelling, making that a non-polar molecule overall. And that would be that question.